kids. Welcome to day 3 of Volumes of Revolution. To recap, you have learned how to do the disc method, and you've learned how to do the washer method. I call them potato chips and lifesavers. Now, they really are the same method. When you're using the disc method, you have no space between your shape and your axis of rotation, so you're taking the radius squared and subtracting nothing. But your washer, you have a space, so you have to take your big radius squared minus your little radius squared. Right? They are the same thing. It's just that for the disc method, your second radius is 0. Now remember, you could integrate either dx or dy with both of these. Here was your decision. Your decision came from if your axis of rotation was the x-axis or was parallel to the x-axis, your strip or your slice was perpendicular to the x-axis. That was dx. For dy, your axis of rotation was parallel to the y-axis. And the strip that you drew, or the slice that you were making, was perpendicular to the y-axis. That was true for both discs and washers. For shells, it's going to be flipped. Shell method, or the bundt cake method, is for that you also are going to have dx and dy, but this time your axis of rotation is perpendicular to the x-axis, and the strip or the slice that you make is parallel to the x-axis. Oh, I meant to do that in blue. Your axis of rotation is perpendicular to the y-axis, and your strip is parallel to the y-axis. Now, students generally don't like the shell method as much as they finally get used to disc and washers, and they're like, okay, I got this, I think. Please don't throw another method at me. And here's the nice thing. AP will never write a problem so that you must do shells, but sometimes shell is more efficient. Again, it's another way of saving you from potentially having to do 2 integrals. But AP will not force you to do shells, right? But on our tests, we will. We're going to make you do shells on a quiz, not this quiz, so actually not the quiz this year, but on our test. Remember, shells is not going to be on your quiz this weekend. So the first thing I'm going to do is show you a problem that requires both discs and washers, and then I'm going to show you how I would use shells in order to do just one problem instead of 2. So the first thing I'm going to do is draw this graph. So I'm bounded. I can't find area, an area used to find volume unless you're bounded. The y-axis is x equals 0. That's one boundary. The other boundary is x equals 2. That's a vertical line. X equals 2 is a vertical line. And y equals 0, which is a horizontal line. And then, of course, the curve. So there's my area. Notice that for a little bit from 0 to 1 here, my shape is right up against my axis of rotation because they asked me to spin this across the y-axis. And they want me to find the volume. So I'm going to spin this thing this way. With washers and shells, my strip, right, my axis of rotation is not just parallel to the y-axis, it is the y-axis. Therefore, to do discs and washers, I'm going to slice perpendicular to the y-axis, which means I'm going to integrate dy. So I'm going to draw a strip for my for my disk method, because I'm going to do my disk method right here from 0 to 1, and then I'm going to do my washer method from 1 up to 5. The intersection between the boundary x equals 2 and the curve x squared plus 1 is 2 squared plus 1, which is 5. So I need to do two problems, right? I'm going to reflect this across, draw the reflection across the axis of rotation. There we go. And I'm going to spin. There's my potato chip. Here's my lifesaver. So I'm going to add up the radius squared dy from 0 to 1. And I'm going to all those potato chips going from 0 to 1. And then I'm also going to add up all the lifesavers from 1 to 5. And I have to add those together. Also notice that since I'm integrating dy, I need to get this equation in terms of x, right? Because since I'm integrating dy, every expression and number has to be in terms of y. So the upper region from 1 to 5, the outer radius r and the inner radius little r, the radius, the first radius, right, the long radius here is just 2, right, because that boundary doesn't change. X equals 2. I already had the x value. But then the short radius, I had to get, right, y minus 1 plus a minus square root. This was the positive piece in quadrant 1, so I have the positive square root of y minus 1. So I have pi going from y equals 1 to y equals 5, big radius minus small radius, both of them individually squared minus 1. And then notice I said I could do an integral here, which I can, but this shape, since the function on the right boundary is a constant and on the left boundary is a constant, when you spin that, can you see that you're just going to get a cylinder? So you know the volume of a cylinder, I hope, right, is just pi times the radius squared times the height. But if you didn't see that, that's okay. I could just add, as I said, this integral. So this integral would be pi. The radius is constantly 2, going from 1 to 2. That's where this formula comes from, by the way. So integrating 4, right, that constant 4 would be pi times 4y from 1 to 2. Notice that that is 4 pi. Now this over here, this is 4 minus the square root of y minus 1 squared is just y minus 1. So it's 4 minus 1 and minus y and then minus 1. I think I typed this out. Right, here's my cylinder, whether I got with calculus or just recognizing I had a cylinder. This was very easy this is also easy integrate, 5y minus y squared over 2. and I ended up with 12 pi. But the important part here was understanding that since my axis of rotation was parallel, or in this case was the y-axis, I had two regions. So I had to do two integrals. It just so happened that this was an actual geometric shape, so I didn't have to integrate that. But still, I had to separate it out. This time, I'm going to do the same problem with the same shape, but I'm going to do shells. The axis of rotation does not change. The shape and the boundaries do not change. But the strip that I want to draw, I have an axis of rotation that is perpendicular to the x-axis. I want to draw a strip to the x-axis, which is parallel to my axis of rotation. Notice when you click and drag, the top of the strip does not jump boundaries and the bottom of the strip doesn't jump boundaries. I am still going to reflect this across the axis of rotation. I'm still going to draw the reflective point here and here, and the image of my strip. But when I spin this, I get this really thin cylinder. And when I do that again here, I get a bigger cylinder. I don't know if any of you know the Matryoshka dolls, right? In the Russian or the Baltic area, the Matryoshka dolls, right, that nestle inside one another. That's what these are like. Shells are like nestling a whole bunch of cylinders inside one another. And all I have to do is add up the volume of all of these, the area of all of these cylinders from 0 to 2. So I have a nicer drawing about this. Take a vertical slice, revolve it around the y-axis. Notice that, again, I am parallel to the axis of rotation. The axis of rotation is perpendicular to the x-axis. The slice is parallel to the axis of rotation. That means I'm going to integrate dx, but I'm going to integrate a shell. So there's a cross section of all of those, right? If I slice them in half, all of those shells, the shells are parallel to the axis of rotation. So I want you to imagine unrolling a cylinder, right? So take scissors and cut. If you cut one of those cylinders, you get a slab, right? Imagine it's a piece of paper, right? It's a piece of paper. Maybe it's 8 by 11. The height of the cylinder is still the height of this paper, right? Or this slab. The radius, what's the radius? This is the radius when you undo, right? Going all the way around this cylinder. Isn't that the circumference? And when I cut it and unroll it, my circumference is 2 pi r. So what is the area of this rectangle? Isn't it 2 pi r times h? And then remember, it has a little thickness. That's going to get me volume. Area times a thickness gets me volume. The surface area of this slab is circumference times the height. To get volume, I need to multiply times the thickness. In our case, what is the height? The height of each one of these shells comes from the function. What's the radius of each one of these shells? The distance from the axis of rotation along the x-axis. So that's just x. I had no shift of my radius. So the surface area is 2 pi times the radius, but the radius is x, times the height, which is x squared plus 1 for every different shell. So the volume of one cylinder is 2 pi times the x coordinate, whatever this is. Let's pretend that's 1.5, times the height at 1.5. And then I just want to add them all up. So there's the volume of one shell. There's the volume of the infinite amount of shells, going from x equals 0 to x equals 2. My radius is in terms of x. My height is in terms of x. And I integrate with respect to x. Pretty cool, right? Notice that you have a constant that you can osmosis out, and it's not pi, it's 2 pi, right? So with washers and with shells, you can osmosis because your formula is pi r squared, because it's the area of the circle, and then, right, multiplied times the width. Here, you have 2 pi r times h, right? It's not pi r squared, it's 2 pi r h. You still have two dimensions, your radius and your height, and then your third dimension is that thickness, which is how you get your volume. Crazy. So I just distributed the x. Osmosis the 2 pi outside. This is an easy integral. X to the 4th over 4, x squared over 2. From 0 to 2, love when I have 0 and variables because that piece goes away. Plug in the 2. 2 to the 4th is 16 divided by 4. 2 squared is 4 divided by 2. Add those together, multiply by 2 pi, and I got 12 pi, which I got before, right? I got 12 pi when I split this into two integrals using disk plus washers. This time I only had to do one integral. This was more efficient than doing washer disk plus washer. I only had to do one integral. The difference being that the strip I drew was parallel to the axis of rotation. The strip is pointing at the x-axis. Integrate dx. Parallel to axis of rotation is where you have the 2 pi RH. Okay, so the shell method is from when the strips you draw are parallel to the axis of rotation. Dx for when you are parallel, your strip is parallel to the y-axis, but strip is perpendicular to x-axis. Nestled cylinders. looks like a bun cake. So here is a cool shape made using the shell method. I have an applet here that we'll investigate when we in our live session that lets you kind of play around with some of these. Kind of cool to watch them being quote unquote made. So here's example 1, and you have a handout that you can, so you don't have to copy all this down. Find the volume. When the region is revolved, the region given is revolved around the y-axis. So there's my axis of rotation. If I wanted to do this with discs or washers, my strip would have to be perpendicular to the axis of rotation. But notice that I would have to get this, right? I would have to get the positive square root, the negative square root here. It could be done, but I want to use the shell method to do this, which means I'm going to draw a strip that is parallel to the axis of rotation. I'm going to take out one of these cylinders. I'm going to create one of these cylinders. Oops, I forgot that I drew it closer. So here's the strip I drew. My strip is parallel to the axis of rotation. I spun it here. Let me draw the image. I don't have enough room to completely draw the image, but you get it. So here is my strip. Here's the image of my strip, and I'm going to spin it, revolve around the axis of rotation to create this one cylinder. I'm going to cut it, spread it out, making a slab to find its surface area. So its surface area is 2 pi times the radius times the height. The radius is measured from the axis of rotation out to my strip. That's an x. The height is from the bottom of the shape to the top of the shape. I started drawing strips at 2 and ended at 8. Those are x numbers, 2 and 8. Radius in terms of x, function in terms of x, slice perpendicular to x-axis, integrating dx, plop this in my calculator, bam. You can leave your answer like this. If you approximate it, you have to write 3 places past the decimal, but you must give them units if they give you units back. Now, in this problem, the units came out of nowhere, right? I didn't tell you they were units. So since I didn't give you units, you wouldn't have to put units on your answer. So let's look at another example, but this time I have the exact same shape, but I want to revolve it around a line x equals -1. Take the same shape. This time I left myself some room. Reflect it. I want to draw a strip. Instead of going across like this and having to get X by itself, I'm drawing a strip in my shape that is parallel to the axis of rotation, but perpendicular to the X axis. So I'm going to integrate dx. Draw the image of your strip and spin. Ooh, I'm off center, aren't I? That is a really thin cylinder. Its surface area, you're going to add a bunch of them. The surface area is 2 pi times the radius times the height. So let's look at the radius. The radius of this cylinder is measured from the center out to your shell, to your strip in the actual shape, not the image. How long is that radius? That radius is not just X. Oh shit. Your radius has been shifted. So your radius isn't just X. It's not just 3. How long is your radius? It is whatever your X value is plus 1. What's your height? Your height goes from the bottom of your cylinder to the top. What is that? That is just the function height. Think about what you would do if this was off of the axes, right? You would have to do top minus bottom. Two pi radius times the height. Where do you start drawing strips? You start drawing strips at 2, and you stop drawing strips at 8. So these two numbers are X numbers. Your radius is an X number. Your function is in terms of X, and you are integrating with respect to X. When I did that, did I write down my answer? I don't think I wrote down my answer. Maybe they just ask you to set it up anyway. Oh no, I did write it down. 192 pi. I didn't give you units. You don't have to give them back. If you round, remember to write 3 places past the decimal. Again, you can verify whether I'm writing down from the right example or not. Let's do another one. Find the volume of revolution Notice that this function is in terms of x. It is bound by x equals 0, and it is revolved around the x-axis. So my axis of revolution is here. And my shape, they want me to revolve it this way. So if I wanted to do washers, remember washers means, again, you have to be perpendicular to the axis of rotation, right? That's when you're doing washers. And then I would also have a space. Again, if I'm going to do washers, I would have to get this equation in terms of y. Y equals x stuff because my strip is pointing at the x-axis. I'm going to draw this strip. Remember, I am bounded by the line x equals 0. There's my region. My strip is parallel to the axis of rotation. Draw your image down here. Draw your representative strip. The image of your strip. Revolve. Sideways. Cylinder. Again, I'm kind of off center. I get it. Don't judge. Since I am parallel to the axis of rotation, but my strip is perpendicular to the y-axis, I am going to integrate dy with shells. The shell method is 2 pi the radius times the height. These numbers are going to have to be y numbers. So hopefully you can see by the graph, my y numbers are 1 to 5. What's my radius? What's my radius? The radius is measured from the axis of rotation out to your shell in the actual shape, not the image. Since my axis of rotation is just the x-axis, I have no shift of my radius. So my radius is just not the x-coordinate, right? The y height. And then what is the width of this cylinder? From the y-axis out to the function, you want to know how long that is. That is an x number. Your x number comes from there. Radius is in terms of y, and you had no shift. Height is in terms of y, integrating with respect to y. These are both y numbers. This one was not too bad to do by hand, right? You would be integrating 2 pi negative 2y cubed plus 12y squared minus 10y. So you'd get y to the 4th. That's a cubed. I said cubed, but wrote squared. So that's y to the 4th over 4. Y cubed over 3 minus 10y squared over 2. Again, I don't need plus c since I'm going to do the fundamental theorem or the integral evaluation theorem from 1 to 5. Well, this is kind of gross, huh? I'm just going to tell you that what you get was 128 pi. If you rounded, 402.124, if I can read my writing right. Okay. So finding volume, it's still a revolution because you are spinning across an axis of revolution. But with shells, you're allowed to make your strip parallel to the axis of rotation instead of perpendicular. Your strip has to be perpendicular to the axis of rotation if you're doing discs or washers. When your strip is parallel to the actual axis of rotation, shell method. Right, so in this case, my axis of rotation is the y-axis. My strip is parallel to the y-axis and perpendicular to the x-axis. That's dx. Remember that sometimes the height of your function is a top minus bottom situation, might be might be f minus g, top minus bottom, or here might be right minus left. Also, don't forget that your radius, you might have an O shift situation. For example, for this example right here, right, the height of my strip would be the top of this function minus the bottom of this function. I would have no shift because my axis of rotation, right, the radius of my cylinder would just be from here out. Draw it. As terrible, my drawings are terrible. Draw it and you can figure it out. When your strip is perpendicular, that's when you use the washer method. And remember, washer and disc is really the same. It's just for the disc, the small radius is 0. Notice still, again, here's my axis of rotation. My strip is perpendicular to the axis of rotation. And I have a lifesaver. Here again, right, you have to be careful of your function being a top minus bottom scenario. Right, and you have to always be careful if your radius has been shifted. Right, if I move the axis of rotation from the y-axis to asking you to revolve around the line x equals 4 or the line -4, the line x equals 10. Okay? Pretty cool, this stuff, though. 3D. Draw it. All right. We will do more practice of this in our next live session.